Good day. Let me present paper written by authors Botlik Joseph, Botlikova Melina and Palova Zuzana, all authors are from the School of Business Administration in Karvina, Silesian University in Opava, from Czech Republic. Title of the paper is A Hierarchical Precedences Model for the Analysis of Teaching Process. 2. Mapping the learning process and its analysis are relatively complicated activities. This paper demonstrates the use of precedents for non-standard analysis. Precedential model and precedence analysis are based on a comparison of element in the system and the search precedents in the linkages between these elements. Links are defined for the element of the system and precedence is set for attributes of element. Multiple precedents and consensus in precedence are examined and modeled using the identified precedents. This way we can find the critical points and critical activities in the educational process. 3. The learning process is essentially composed of a set of elements and the links between them. A good definition of these elements and links can be for modeling and analyzing to use of classical methods of systems theory, systems analysis, operational analysis and graph theory. Standard methods and optimization tasks provide a similar set of results, which is nowadays usually applied. To increase efficiency, analysis and modeling is a need to find new, non-standard methods and procedures that extend the methods used previously. These new methods must fulfill several conditions: universal application, simple applicability to existing structures, existing methodologies and mathematical apparatus. Precedence analysis is based on the basic definition of the general system. The system is defined as a set of elements and links between them. Each element has a assigned set of attributes. Precedence analysis compares the values of selected attributes of the element that have defined common link. Comparison can be absolute values of the attributes or purpose-defined changeover value. Relative increases over, the absolute increases over time, relative increases in space, absolute increases in space, deviations from the average values, deviations from the maximum values, deviations from the minimum values, etc. By comparing these values we get between so ever defined pairs of element of the direction of flow values for a given attribute. 4. The basic model is multi-level model. The first level consists of a set of incidence matrices. The second level consists of the matrix of values of attributes. The third level consists of a set of precedence matrix. Precedence matrix is generated for the attribute from vector of attribute values and the incidence matrix. Over the set of precedence matrices are performed basic system operations. Based on these operations, we can determine a set precedence for the selected element, set precedence on the set of selected element, existence of precedence multiple lengths between two element, and frequency of precedence multiple length between the two element. The set of operations, then we can extend the searching set succession to set precedence and vice versa. 5. The first level consists of a set of incidence matrices. Incidence matrices are defined for different types of links. The basic set consists of matrices for transitions between years, matrices for links between sections, matrices for links between objects and other. Incidence matrix is a square matrix that records the existence of the link. With the implementation of the matrices, to model we change the structure of the model. Incidence matrix is easily modifiable and universal. 6. The second level consists of the matrix of values of attributes. In the absence of the attribute values in the relevant surroundings, attribute value is counted using a set of keys, minimum, maximum, average, etc., from the attribute values of element of the system. The values of one attribute are therefore described by the row vectors. Matrix of values of attribute is again easily modifiable and universal. Comparing the values of attributes a specified direction of flow. 7. The third level consists of a set of precedence matrix. Precedence matrix is generated for the attribute from vector of attribute values and the incidence matrix. At this level, are compared values of the selected attribute between each pair of element. Subsequently, based on the value of the element of incidence matrix, it is determined whether there is between element the appropriate type of linkage. In case of a linkage is determined by binding orientation direction from an element with a lower value to an element with a higher value of the attribute. 8. Over the set of precedence matrices are performed basic system operations, composition operations of the selection vector with matrix and unification of selected vectors is defined for the model. Based on these operations, we can determine a set precedence for the selected element, set precedence on the set of selected element, existence of precedence multiple lengths between two element, and frequency of precedence multiple length between the two element. The set of operations, then we can extend the searching set succession to set precedence and vice versa. 9. The paper demonstrates universal precedence model suitable for the analysis of the learning process. Forte of the model is universality. When we define independently a set of element, a set of attributes and a set of links, this independence allows creating many of independent structures, and carrying out time-independent and space-independent analysis. Changing the structure is easily reached selecting the relevant incidence matrix. Change the parameters of the system is realized by changing the vector of attribute values and calculating the appropriate precedence. 10. The model is applicable wherever where we work with disparate values, number of students, study programs, continuity on subjects, etc. Furthermore, where we work simultaneously with the state variables, number of students, number on subjects, etc., and with flow values, increase the number of students, duration of study, etc. The model allows analyzing even flow operation between the surroundings and the system, allows defining more types surrounding, for instance unsuccessful students after first year, unsuccessful students after the second year, students who transfer to another school, students who come from another school, etc. The paper demonstrated on concrete examples a fraction of the model options that exceed the scope of this paper. Thank you for your attention.